Welcome to the DC Department of Energy and Environment's General Compliance Training on Stormwater Management. This is part of a series of trainings on stormwater management that can be found on the DOEE website. The objectives of this training are as follows: to know when the stormwater rules apply, to calculate the stormwater retention volume, or the SWRV, for a site, to understand the difference between a site drainage area and a contributing drainage area, to understand the basic concepts of the BMPs in the guidebook and the important design considerations of them, to understand the public right-of-way and how to meet your stormwater obligations to the maximum extent practicable, to know what an off fee is, or an off-site retention volume, and how to comply, to understand the overall process of submitting a plan and having it approved, to know what the surface and groundwater system is and how to access it, and to understand when detention is required. These topics will be covered throughout various videos in this series. Chapter 2 of the Stormwater Management Guidebook covers the stormwater management requirements and when they apply. To understand the stormwater management program in DC, we first need to understand what retention is and why we care about it. Retention refers to capturing and storing over the long term stormwater runoff. The advantage of capturing and storing this runoff is that it prevents any of the pollution that runoff is carrying from being transported further down into any receiving water body. This is in contrast to detention, which is the practice of capturing and only temporarily storing and then passing that runoff on down. So retention is the long-term storage that sort of removes that runoff volume and the associated pollutants out of the equation. It's also referred to as runoff reduction. Now, the volume of runoff that's required to be retained on site is called the stormwater retention volume, or the SWRV, and it's a function of the proposed site conditions and the precipitation depth that is regulated. So you can see here in this equation, the precipitation depth in inches is multiplied by this composite of the runoff coefficients and the areas for different land cover types in the proposed condition. So you can see for each land cover type, impervious, compacted, or natural cover, there's a different coefficient assigned, where the impervious cover is basically anything you would think of as impervious. So that's concrete, parking lots, rooftops, that sort of thing. And it's assigned a coefficient of 0.95. So about 95% of the precipitation that lands on an impervious cover is translated into runoff. The natural cover is at the other end of the spectrum. This is natural areas that are not regularly maintained. So woods, meadows, that sort of thing. And it's assigned a runoff coefficient of 0. So essentially saying that at the storm size that we're regulating, the runoff from that parcel or that area of natural cover is going to be 0. Right? And then compacted cover is everything in between. So this is generally turf areas, lawns, any compacted urban soils might have mulch on it, that sort of thing. And it's assigned a runoff coefficient of 0.25, right? So about a quarter of the precipitation that lands on the compacted cover translates into runoff, according to this formulation here. There are some conversions in this equation to get it from gallons and feet and cubic feet and to get all the units to match up. So this is the way that the SWRV, or the stormwater retention volume, is calculated for the proposed site. Now, as I mentioned, the precipitation depth can be regulated to different levels. So there are different types of activities that can be proposed on a site. So one of them is a major land disturbing activity, or MLD activity. And this is defined as any activity that disturbs or is part of a common plan of development that disturbs 5,000 square feet or greater of land and has either any portion of the pre-project land cover as natural or a 2,500 square foot or greater post-project land cover that's impervious or BMP area. So if it meets these conditions, then the site activity is considered major land disturbing activity, and it's regulated to the 1.2 inch precipitation depth. The other type of activity is major substantial improvement activity, or MSI activity. And this is where you have a substantial improvement activity, where a substantial improvement activity is defined as construction where the costs for building, renovation, or addition are greater than or equal to 50% of the pre-project assessed value of the structure. So that's what makes it a substantial improvement. And what makes it major is the combined footprint of that structure that's being renovated or added onto exceeds the cost threshold and the land disturbance associated with that project. Those two together, the footprint and the land disturbance, are greater than or equal to 5,000 square feet. And again, those two conditions, one of them being the pre-project land cover is in any way natural, or the 2,500 square feet or greater of post-project land cover is impervious or BMP area. So if it meets these conditions, then the site activity is considered major substantial improvement, or MSI, and it's regulated to the 0.8 inch precipitation depth. There are some additional requirements that apply if you're in this Anacostia waterfront development zone, or the AWDZ, and you meet certain conditions in your projects. So if you have a project in this red outlined area here, be sure to check in Chapter 2 of the guidebook to see if the project meets the conditions for an AWDZ project, because some additional requirements will hold. Those precipitation depths that I just mentioned are slightly different in this zone, and there's an additional water quality treatment volume that must be addressed. There are some convenient flow charts that can be found in the Stormwater Management Guidebook that can help walk you through the process of determining what type of activity is going on in your proposed condition on a site, and what regulatory rain event would be applied to the area that you're either disturbing or the area that you're improving the footprint of the building. So I won't go through this in detail, but you can walk through this flow chart and a couple of others in Chapter 2 of the guidebook. There are also some additional requirements or considerations, not just on the overall site area, but on each individual site drainage area. So the site drainage area, it'll be discussed in detail later, but it's defined as where the runoff leaves the site. So each area on a site, if they direct runoff, say for example, 2 areas of the site direct runoff in different directions, you would have 2 site drainage areas. So for each of those site drainage areas, or SDAs, you would have to look at making sure that the minimum requirements are met for each of those site drainage areas. And it can differ based on whether you're in the MS4, the Municipal Separate Storm Sewer System, or if you're in the Combined Sewer System, the CSS. The charts, as I mentioned in Chapter 2, these flow charts can help walk you through that process to make sure that you're meeting the minimum requirements based on your site conditions. And this flow chart just gives some additional aid in determining if those minimum requirements are met for the site drainage areas and the site overall. So let's look at some examples. This first example is a simple one that is a major substantial improvement. And the example site shown here is just an existing building, 5,000 square foot footprint. The assessed property value is 1.5 million, and the renovation cost is 750,000. So the proposed renovation is 50% of the assessed property value. So by that we know that it is a substantial improvement. And the major part comes in when we look at the footprint. So we can see, since it's an existing building of 5,000 square feet, the total project footprint is 5,000 square feet. So this is a major substantial improvement. Right? The third condition there being kind of implicit, that the proposed site condition is going to have 2,500 square feet of impervious area or greater, because the building is going to be impervious. So the swerve regulated rainfall depth is going to be the 0.8 inch. So in that swerve equation that we saw earlier, you would use the 0.8 inch precipitation depth for the P to calculate what your swerve is for this project. A second example here is very similar. You have two buildings on a site, one of 4,000 square feet and one of 1,000 square feet. So in this case, you would look at each building individually, and you would look at the renovation cost for building A and the renovation cost for building B, and then compare it to the assessed property value of each building. And in this case, each of building A and building B has a substantial improvement activity proposed because of the cost exceeding that 50% threshold. And the overall project area with the two buildings together is 5,000 square feet. So we have a major substantial improvement. And the swerve regulated rainfall depth for this project is again going to be 0.8 inches. This example here, and I should mention all of these examples are in an appendix of the Stormwater Management Guidebook. So this building has a 4,000 square foot footprint, and then there's going to be some proposed work adjacent to this building, 1,000 square feet of proposed compacted cover. So we'll look again at the building renovation cost to see if this is a substantial activity. So this improvement is $400,000 proposed renovation cost compared to the $800,000 assessed property value. So the percentage of the property value is 50%. This is a substantial improvement. And then we look at the footprint. So the 1,000 square feet of disturbed area, this cover that is going to be proposed as compacted cover is 1,000 square feet. Adding that on to the 4,000 square feet of the building footprint gives a total project footprint of 5,000 square feet. And here we're looking at the post-project impervious cover, which is going to be the footprint of the building in this case, since the other 1,000 is compacted cover. So we still have more than 2,500 square feet of proposed impervious post-project impervious cover. And because of all these conditions together, this substantial improvement, the 5,000 square feet of total project footprint, and the greater than 2,500 square feet of post-project impervious area, we have a major substantial improvement project and a swerve rainfall depth for this project of 0.8 inches. Moving on to the next example, we have a very similar example where you have a 4,000 square foot building that's going to be renovated, and then you have some associated land disturbance. In this case, though, the land disturbance is in the public right-of-way, which will change our situation slightly. But we're going to go through the same process. First, look at the existing building. So the activity that's proposed is 50% of the property value, so this is substantial improvement. And the total footprint is the 4,000 square foot building footprint and the 1,000 square feet of land disturbance area in the public right-of-way. So there's 5,000 square feet of project footprint. And then we're going to look at the post-project impervious cover, of course. Again, the same situation where we have 4,000 square feet. So we have a major substantial improvement, but the 0.8 inch precipitation depth is only going to be applied to the 4,000 square foot footprint of the existing building. The disturbance in the public right-of-way is going to have to meet a 1.2 inch precipitation depth because all disturbance in the public right-of-way, whether it's part of a major land disturbing project or part of a major substantial improvement project, it must be applied the 1.2 inch precipitation depth. There is a special consideration, though, for the public right-of-way, which we will go over in another training of this series, where we talk about the maximum extent practicable process, or the MEP process. And this is the process where you can demonstrate all of the constraints and demonstrate that you're doing everything possible in this public right-of-way to get the swerve met up to that 1.2 precipitation depth, but recognizing that there are constraints within the public right-of-way. I'll go into that in more detail in that training. So let's look at a more complicated example here. So now we have an existing building with 4,000 square foot footprint. We have 3,000 square feet of proposed impervious cover and 4,000 square feet of compacted cover. So looking at this cover, this disturbance area, on its own, we have 3,000 plus 4,000 square feet of total disturbance. So on its own, we have 7,000 square feet of disturbed area. So that 7,000 square feet is going to constitute a major land disturbing area because we have greater than 5,000 square feet of disturbance and we have greater than 2,500 square feet of impervious cover. Right? So that area, that 7,000 square feet of land disturbance, is going to have to meet the swerve to the 1.2 inch precipitation depth. While the 4,000 square feet of the existing building, since it constitutes a substantial improvement, right? The proposed renovation is 50% or more of the assessed property value. So that 4,000 square feet of the existing building is only going to have to meet the swerve up to a 0.8 inch precipitation depth. Right, so you have a mix of activities here on this site, a major substantial improvement applied to the 4,000 square feet of the building, and a major land disturbance associated with that 7,000 square feet of land disturbance. Here's an example that we don't see all that often, but it has happened. This is a site that has an existing building of 5,000 square foot footprint and an associated impervious cover of 2,000 square feet and 4,000 square feet of compacted cover. So we can look at the disturbance here. We have a total of 6,000 square feet of disturbance, but while it meets that threshold of the 5,000 square feet of disturbance, it does not meet the threshold of the 2,500 square feet or more of post-project impervious cover. So the disturbed area does not constitute a major land disturbing activity. And then looking at the existing building is not a substantial improvement because the renovation that's proposed is only 40% of the assessed property value. So for that 5,000 square foot building footprint, no stormwater management is required because it doesn't meet the definition of a major substantial improvement activity. So we have neither a major substantial improvement activity nor a major land disturbing activity, and so there is no stormwater regulated activity on this site. In addition to the retention requirements that I've been discussing up to this point, there are also detention requirements or quantity control. And these must be controlled from the site discharge in terms of the peak discharge. So we want to control the peak discharge to pre-development conditions for the 2-year storm and control the peak discharge to pre-project conditions for the 15-year storm. There are also cases where the peak discharge must be controlled for the 100-year storm. This applies only if the project is in the special flood hazard area, SFHA, or it may cause flooding to a building. I'll go over this detention component of the requirements in a separate training. There are some important exemptions to the retention and detention requirements. The retention exemptions are as follows: the athletic playing fields or permeable athletic tracks and permeable playground surfaces. All of that area is exempt from retention requirements. From the detention requirements, the major substantial improvement activities are exempt, and work in the public right-of-way is also exempt from detention requirements. There are some categories of work that are exempt from both retention and detention requirements, and these include disturbance for BMP installation. So if there's a voluntary work that's just for the sake of installing a new best management practice, that area is exempt from both retention and detention. And utility work, so linear utility work that is an area solely for utility work. This does not include utility work that is on a site where the other improvements are proposed on or around it. This is simply for the linear trenching of utility work. That area is exempt from both retention and detention. There's also a process called the practicable process, which is an important consideration in some situations. This practicable process, it's similar to the maximum extent practicable process for the public right-of-way, but this practicable process applies to certain situations, including affordable housing, trails, and small structures at parks like baseball dugouts. These are situations where DOE recognizes that it's very difficult and oftentimes counterproductive to apply stormwater management regulations to these activities.